Now let's look at different types of symmetry. We've got two different types we're going to look at, and they tell you whether you have an even function or an odd function. So let's start with the even function. An even function is symmetrical about the y-axis. So if you have y-axis symmetry, let me spell that right. If you have y-axis symmetry, that means if you folded it across the y-axis, it would fold onto itself. So here I've got the graph of x squared. If I folded it across here, this would fold onto the other side. So that parabola, as long as it's centered on the origin, has y-axis symmetry. Now, to show that, that's graphically, but to show it algebraically, if I give you an equation and say, is this an even function? To check that, f of x has to equal f of negative x. What that means algebraically is if I plug in negative x everywhere there's an x, and I get back the same function, then it's an even function. So, for example, if I asked if x squared plus 4 is an even function, I would take f of negative x, which means I'm going to plug in a negative x everywhere there's an x. And notice that x squared is negative x times negative x. And a negative times a negative makes a positive. So that gives you back x squared plus 4. So notice that is the same function that you started with. Thus, it is an even function. So if you plug in negatives for all the x's and it gives you back the exact same function, it's even, which means it has y-axis symmetry. Now, an odd function, you might just assume that that means it has x-axis symmetry, but notice if we had something that had x-axis symmetry, let's say like this, that's symmetrical across the x-axis, that is not a function because it doesn't pass the vertical line test. So when we're talking about even and odd functions, x-axis symmetry wouldn't be a function. So here, when we say an odd function, what we want to know is if it has origin symmetry. And origin symmetry is a reflection across both the x and the y axis. Or it would be a rotation of 180 degrees. Both of those would give you the same thing. So if I flip this across the x-axis and then again across the y-axis, it would lay back on itself and be the exact same function. So if I did flipped it once across here, it would look something like that. And then if I flipped it again, it would flip back on itself. So that would be origin symmetry. Now again, this has a different test, or it's the same test, but you get a different result. To be an odd function, if I plug in a negative x, I need to get back the opposite of my original function. So basically, all the signs need to change. So let's look at this function. If I have f of x equals x cubed plus 2x, and I want to check to see if it's even or odd, I'm going to plug in a negative x, which would be negative x cubed plus 2 times negative x. So if I have negative x cubed, that's going to be negative x times negative x times negative x, which 2 will give you back positive, and then you have a leftover negative. So that'll be negative x cubed plus a negative 2x, or just minus 2x. So if you notice here, if you compare this to your original, it has all opposite signs, which means it is an odd function. So if you plug in a negative x and it gives you the same function, you're even. If it gives you opposite signs on every term, it's an odd function. Now let's look at one more example. If I wanted to check if this one was even or odd, I've got 2 times negative x to the 4th plus negative x to the 3rd. Notice that this one, when I have it to the 4th power, it's going to give me back an even, so I mean a positive function, or x value. So I've got 2x to the 4th, and this one to the 3rd is going to change that to a negative. So notice here, if I compare it to the original, it's not the same. And it's not completely opposite. So to be completely opposite, this would have to be negative also, and it's not. So since that's not negative, this is neither even or odd. So it doesn't have to be even or odd, it can be neither. So just keep that in mind as you're doing your homework, that it can be one or the other or neither.